In ACI 621, you have a handful of features that have come out, and one in particular that I don't want to go unnoticed is span to CPU. Span to CPU has been around in standalone NXOS for quite some time, and as a previous TAC engineer for both standalone NXOS and ACI TAC teams, it's something that I've always hoped ACI would take advantage of. It's definitely a tool that can help progress troubleshooting when there's no host to receive span or span traffic. Now, for those not familiar with span to CPU, it's like a local span or span where we mirror traffic to a host that's either locally attached to the leaf or remotely to another. However, here, we're actually going to mirror the traffic to the CPU of the local switch. Now, there are a few limitations listed here, and I'm not going to go through all of them, but I will call out a few. First is going to be that this is supported on FX2 switches or newer. If you try to configure this on unsupported hardware, the APIC will accept that configuration, but when it tries to push that configuration down to the switch, it's actually going to generate a pair of faults. I'll go ahead and show that later in the demo just so you can see what it looks like. The next thing I want to call out is that this is for local spans only. There's no creating a span on leaf 1 and sending it to the CPU of leaf 2. And the last thing that I will call out is that this feature is rate limited to 500 kilobits per second. Why and what does that mean? Well, that is basically in place to protect the CPU from being overwhelmed with the mirrored traffic. What does that mean in terms of how the tool is used? Well, if you're using a heavily utilized interface, let's say even just a 10 gig interface, and you're receiving 8 gigs of traffic, the span or mirrored packets are only going to be a fraction of what's actually coming into the interface. There might even be a possibility that you might have to run the capture a few times to see the traffic that you're looking for. It might not show the first time. Generally, this tool is good enough to observe and confirm whether the flows that you're looking for are present, at least from my experience thus far. Before starting the lab, I'm going to go ahead and show you the topology I'll be using. It's a pretty simple lab. It's basically 2 leaves connected to a spine, and I have a host connected to each leaf, and host 1 is pinging host 2 and host 2 is replying. Now, I could use ELAM to help me validate the forwarding decisions of the leaf, as well as tell me stuff like what the interface is, what interface the traffic is ingressing on and where it is egressing, or even if the switch is dropping it. But ELAM is limited to 1 packet. What if I have intermittent drops? What if I'm trying to see a certain packet in a sequence? This is where span, and more specifically in our scenario, span to CPU will help. Our next step is going to be to configure a span session, and what I'm going to use as a destination interface of the leaf is going to be the CPU of leaf 1. Let's go ahead and get started with our demo. Okay, everybody, I'm here on the APIC UI, and to get span configured, what we're going to do is we're going to go ahead and go to Fabric, Access Policies. We're going to go down to Policies on the left, and we're going to expand troubleshooting and expand span. And we're going to create a destination group. So for our destination group, let's just do a span dest. We're going to click Access Interface, and we're going to select node 1. And you see the first interface here is soup eth0. This is what we're going to use to go to the CPU. So I'm going to set that. I'm going to hit submit. Let's go ahead and create a source group. And we'll call this span demo. And I'm going to select the destination group that we just created. And let's go ahead and add a source interface. And we're going to configure this on node 101. We're just going to use the first interfaces where our traffic is coming in. Go ahead and hit OK, OK, and submit. And you see we have this done. Let's go ahead and validate that on the CLI. I'm here on leaf 1, and let's go ahead and validate via the CLI to make sure our monitor session was configured correctly. For that, we're going to use the command show monitor session all. And you do see that we have our span demo set up. It is using the destination, the soup eth0 interface as a destination. We are spanning both ingress and egress of eth11, and the state of the session is up and active. So there is a command that we can use to look at this live here on the CLI. And I'll go ahead and paste this in and we can review the command together. So reviewing the command, the TCP dump command is the standard TCP dump command that we're all used to using. There are a couple of flags that are set here. This XX is telling it to also include the link layer information in hex. And the interface that we set is the Tahoe 0 interface. Now, the Tahoe 0 interface is the interface that we use for all the broadcast traffic that's sent to the CPU of the switch. So you will see ARP traffic, you will see Glean traffic in there as well, and it can definitely be pretty chatty. Now, with this span, we're also going to include our span to CPU traffic, so we need something to parse that out. And included in the OS for 16.2.1g, we have a script, which is a span to CPU parser. Now, what this is going to do is extract all our span to CPU traffic and display it here for us. There are a couple of flags that we do need to include, which is the decoder flag and tell it to decode from the Tahoe 0 interface. There is a verbose flag that will give you a lot of additional header information from ACI that we use internally, and the payload information to include that as well. Now, for the purposes of this demo, what I'm going to go ahead and do is I'm going to just take off these last two flags right here, and I'm going to limit the capture. Let's just say 100 packets. And that way it doesn't fill the screen, and it'll be a little bit easier for us to read here. So starting that capture, and you can see we do capture some traffic from the host in particular that we're looking for. And you can see that here we have the VLAN, we have the MAC addresses of where the traffic is coming from. And you can see here that we have our IP for host 1, sending an ICMP request to the IP of host 2. And then the next one is going to be the ICMP reply from host 2 to host 1. Now, what if you wanted to see this outside of the CLI? Maybe you need to take this and review offline. We can do that as well. And we can include the flag right here, and then we'll send this to the boot flash, and we'll just call this span pcap. And I'll go ahead and just increase the count a little bit, and we'll do 1,000. Let's go ahead and take a look, and to validate that we do have that pcap, we can go ahead and just check that directory. And you can see that we do have that capture right there. It's ready for us to go ahead and SCP or SFTP to the switch and pull it off for further review. Next, what I want to show you guys is how this would look if we configure this on hardware that is unsupported. My Leaf 2 device is actually a 93180YCEX device. And what I'm going to do is I'll go ahead and configure the span session there, set the parameters to send it to the CPU, and I'll show you the faults that the UI will generate. So I went ahead and I configured the span session on the EX device off camera, so then that way just save a little bit of time here. But you can see here that we did generate two faults. The first one being is that it's telling you that the node, the destination in node 1 and 2 is in a failed state. There's no operational source or dest. And the next one is telling you that the span source interface ETH11 on node 1 and 2 is in a failed state. Reason: hardware error. And the reason that we're getting this, as we know, is because the EX device does not support the span to CPU feature. The life cycle does show soaking, but this is going to go ahead and go back to raised and in a few minutes. And yeah, that's pretty much it. Let's go ahead and validate from the CLI perspective of what it shows for this span session. So I'm here on Leaf 102, and let's go ahead and run our command show monitor session all. And we can see the span that I configured, EX switch ETH11, and we can see that we're trying to span ETH11 interface, and we have the CPU set as a destination. But you see the state shows that it's in a failed state. So this is what we expect, or what we expected, because this is unsupported hardware. All right, well, that's about it. I hope this has been informative for you guys. We'll catch you next time.